So I went to the library and got this, Mountains of Fire. The Nature of Volcanoes. Its copyright date was 1991, reprinted 1992. I was 6, so I'm 34 now, and I made the discovery of what Earth is when I was 26. So 20 years I made the discovery after this book was printed. And I can answer something in here that really gets at the heart of the issue of stellar metamorphosis, and it really helps us out to understand things. What is a volcano? Erupting volcanoes are mountains gone mad, as the residents of Armero found to their sorrow. Accounts of their violent behavior appear in the mythology of almost all cultures that evolved in volcano country. Greeks, Romans, Indonesians, Japanese, Icelanders, and Hawaiians all had gods or goddesses of fiery volcanoes. Generally, the beauty and serenity of those deities prevailed, but when aroused and angry, they were poised ready to rain destruction on the countryside. The word volcano comes from the island called Volcano off the southwest coast of Italy. Because of frequent eruptions on the island, Romans considered it to be the forge of Vulcan, the god of fire and maker of weapons. The word has since come to mean any vent in the Earth's crust through which magma reaches the surface. The term volcano is also used to describe the landform built by eruptions from the vent. Just when meaning is implied depends on the usage of the word. Just which meaning is implied depends on the usage of the word. For example, saying Mauna Loa volcano spewed lava over many square kilometers of land refers to the volcano as a vent. On the other hand, to say that Maulao, I think I'm saying that right, is the largest volcano on Earth refers to the volcano as a mountain. And then you have your different types of what geologists call vents. You guys see that? Now, what it is in stellar metamorphosis, it is a vent. That's why I wrote this paper up. I tried to make it as easy to understand as possible, literally like fifth, sixth grade writing so everybody can understand. I wrote, what are volcanoes and why do they exist? Right here. It's not on Vixer yet, but it'll be up there soon. Geologists do not know what volcanoes are and why they exist on Earth. Well, they kind of do. They know that they're vents. But what does that really mean? Why is there liquid magma coming out of the ground? Like, this is the most surreal thing ever if you think about it. Like, the ground's just rock. Why is there liquid rock coming out from underneath the Earth? As a kid, I've always wondered that. I was like, why? What's going on here? This is so strange. And you know, when you're a kid, you used to play The Ground is Lava in your living room, where you run around, jump from couch to couch, from chair to chair, and with your friends or your cousins or whatever, or your brothers and sisters, and you pretend that the ground is lava, and you try to escape it and go from room to room without actually touching the ground. But anyways, and why do they exist? Why isn't the Earth just one solid crust? Why is there liquid rock coming out from underneath? Why is liquid rock? And this paper addresses it. And basically what I have here is volcanoes are the areas in the Earth's crust where heat can escape from earlier stages of evolution. Now, I have Earth as an evolutionary structure. Geologists do not have Earth as an evolutionary structure, which is why they're going to be misguided with a lot of the ideas they have. To them, Earth was always the size it is now and will remain this size forever and ever more. As well, the 4.5 billion years plus of evolution that Earth even went through, Earth never really changed according to the geologists. I mean, sure, there was some what they call outgassing and whatnot, but the mass of the Earth, the characteristics of the Earth, it was all basically the same size when it formed around the sun, according to their theories and models. But as anybody that's read this theory, that's misguided, and it sort of neglects the history of how Earth formed. Well, it neglects all the history of how Earth formed. I did a little drawing here. This isn't on the Vixer paper, it's just in my little talk here. I have a gas giant with no crust and no volcanoes. I have a newly forming crust inside of a water world, which is a very highly evolved gas giant, which has lost a majority of its hydrogen, which is already combined with oxygen, making the water. And then I have on the very right-hand side, fully formed crust with old volcanoes. And if you'll notice, there isn't any crust here. It's just a accumulation of really dense material, and the crust, it's just too dense, it's too hot. A crust can't form in a gas giant yet on the interior. But there will be a large core, a large diffuse core, which is very, not diffuse density-wise, but diffuse, not really differentiated core. And then it goes through many other stages. I didn't draw them here clearly. I just went straight to the water world stage where Earth had very thick water oceans. And the newly forming crust will have very, very tenuous volcanoes and vents that are coming up through the bottom, reaching into the deep water oceans of the ancient Earth. And eventually those water oceans dissipate, leaving the surface volcanoes to continue erupting and to continue releasing the leftover heat in a much more tame fashion. When we think of volcanoes, we think they're extremely energetic, they're extremely powerful, they're very dangerous to be around, they spew hot gases, ash. There's pyroclastic flows that are slow, some that are fast. You have rivers of lava that can reach the surface. You have fissures. You have a lot of different types of material things that happen. And one of the things I just remembered is like with granitic lavas, in the I think it's the Yellowstone. Yeah, you have large, what are called, I think they're called regoliths, I can't remember, but basically really large granitic formations that peak out of the surface of the crust and make basically mountains. You got to remember, the Earth had an enormously vast, thick atmosphere that was very, very dense, that was encapsulating the entire crust. And a lot of the magmas were very, very different than what we see now. There were granitic magmas, and a lot of their compositions were very, very different. But I mean, the geologists, they realize that, but they don't realize how huge the Earth was in its past. So the pressures, the temperatures, the density of materials, all that stuff was different when the very early volcanoes were forming inside the crust. And this also explains why there's gas trapped inside volcanoes. You would think if the Earth formed from rocks clumping together, why is there gas trapped? Why is there gas trapped in the crust of the Earth? Well, it's because when the crust was forming, there was gas being trapped from the Earth's earlier stages of evolution. There was gas being trapped in the crust. And that gas is still trying to escape out along with the additional heat right on the surface. It's trying to leave the interior when it was trapped. But yeah, and this trapping of material is already happened because Earth is 4.5+ billion years old. And in this paper I have here, the volcanoes sort of rat the astronomers and geologists out. The evidence that we have concerning volcanoes and volcanism in the solar system kind of make the geologists scratch their head, like, why is this happening like this? Why is it that Mercury, the majority of Mercury's volcanoes are basically non-existent? Why is it we barely see any volcanoes on Mercury? Why is it that Venus has a bunch of shield volcanoes and doesn't have a magnetic field, doesn't have any active volcanism? So the shield volcanoes are all extinct. Why is that? Why does Mars have Olympus Mons? Why does it have one giant shield volcano in one spot? And basically what this amounts to is that all these objects in our system are all vastly different in age. They're all in different stages of their own evolution. I have here Earth. These are from previous papers. I'm not going to link them like reference style. It's too time consuming. But Earth, I have about 4.5 billion years old plus. And then EA means Earth's age. So Mars is about 20 to 30 billion years old. Venus is about 450 to 700 billion. And Mercury is just insanely old. It's 1,555 to 7,280 times as old as the Earth. So naturally, if there's going to be evidence of volcanism on Mercury, there isn't going to be. It's had a lot of time to wander the galaxy and to get irradiated and to have a lot of its material disintegrate back into outer space. 1 trillion years is a lot of time for an object to get ripped apart by orbiting multiple different host stars in its past. And I think Mercury has been around between 7 to 32.75 trillion years based off of its gyrochronology estimates. It's total angular momentum, in other words, and the fact that its inner core size is about the same size as Earth. So I did that in another paper. I don't want to talk about that right here. I'm just going to focus on volcanoes. But basically, yeah, volcanoes on the Earth are unique. And the reason why it's like this is Earth is old enough to have formed a solid surface crust internally from gas giant stages of evolution. It is young enough to still have remaining heat escaping the surface. It is evolved enough to have had the vast majority of its supremely thick atmosphere dissipated so we can see them. And the heat escapes it as liquid rock, and sometimes it's superheated gas, but definitely not as plasma. And another idea here, that's the end of my volcano talk, but I just want to share something else with you guys. I want to show you how many people have been reading this theory, and I did a little cut and paste off the Vixar website. I don't think you guys, you see like maybe a couple dozen views on some of these videos that I put out, but the truth is that there are a lot of people seeing this theory. Paper number 62 has a total of 4,151 unique IP downloads. That's a lot of eyeballs. And the paper number 322, which is the General Theories of Metamorphosis, version 5, the most updated version, that has 1,523 unique IP downloads. A lot of people are starting to pay attention to this because, well, from my perspective, it's the only theory that really makes sense to explain what the Earth is, what all the planets are, what the stars are. And hopefully one day we break free of specific dogmas that sort of just hold us back and prevent us from understanding what nature really is and how incredible the universe really is. And I'm still waiting for that day. I'm thinking that these papers are going to have tens of thousands of views over time. And I think maybe one day that the amount of views on there is gonna show that, yeah, the dogma is dissipating and the astronomers are changing their ways and sort of realizing that they've been lost the entire time. But it takes some sort of ego check. You have to put your ego on the back burner, and it's very difficult for these people to do that. So, but I mean, we can hold out hope for them maybe. All right, guys, take it easy.